Imagine for a moment that you're standing under a clear night sky. As you gaze up at the countless stars twinkling above, a question bubbles from the depths of your mind. Are we alone? This simple query has haunted humanity for centuries, but in the last few decades, it's taken on a new, perplexing dimension. Welcome to All Sci Fi What If, where we explore the most mind-bending thought experiments in science and technology. Today, we're diving headfirst into one of the most captivating puzzles in astronomy, the Fermi Paradox. Picture this, a universe so vast it boggles the mind, so ancient it makes our civilization look like a cosmic newborn. Now, in this inconceivably huge playground of stars and planets, ask yourself, where is everybody? This is the essence of the Fermi Paradox, first posed by physicist Enrico Fermi over 70 years ago. And despite decades of searching, we're still scratching our heads. But fear not, space enthusiasts. Science marches on, and new theories are emerging that might just crack the cosmic conundrum. So strap in, because we're about to embark on a journey through some of the most fascinating and mind-bending ideas in modern astronomy. Before we dive into the theoretical deep end, let's take a moment to appreciate the sheer scale of the problem we're dealing with. Brace yourselves, because these numbers are about to get astronomical. Our cosmic home, the Milky Way galaxy, is a sprawling spiral of stars, gas, and dust spanning a mind-boggling 100,000 light-years. Within this vast cosmic metropolis, we find ourselves among an estimated 100 to 400 billion stars. That's billion with a B. To put that in perspective, if each star in our galaxy was a grain of sand, you can fit an Olympic-sized swimming pool, and then some. But wait, there's more. Thanks to recent advancements in astronomy, we now know that most of these stars host planets. The current estimate, there could be up to 40 billion Earth-sized planets orbiting in the habitable zones of star-like suns and red dwarfs in the Milky Way. That's 40 billion potential Earths. Now let's do some cosmic math. Our galaxy has been around for 13.6 billion years. Life on Earth appeared relatively quickly in geological terms, popping up around 3.5 billion years ago. Intelligent life? We've only been around for a cosmic blink of an eye. Given these numbers, even if the odds of life evolving are incredibly low, and the chances of life becoming intelligent are even lower, we should still expect the galaxy to be teeming with alien civilizations. Some of them should be millions, if not billions of years ahead of us technologically. So where are they? Why haven't we detected their radio signals, seen their megastructures, or even visited by their probes? The cosmic silence is deafening, and it's the heart of the Fermi Paradox. But don't despair. The absence of evidence isn't necessarily evidence of absence. In fact, this silence has spurred some of the most creative and thought-provoking theories in modern science. So let's dive in and explore some of the latest attempts to solve this galactic mystery. Imagine if you can choose to sleep through the hot summer months and wake up when the weather is cooler and more pleasant. That's essentially what aestivation is, a form of dormancy in animals to survive hot and dry periods. Now let's scale that up to a cosmic level. Enter the Aestivation Hypothesis, a mind-bending theory proposed by Anders Sandberg, Stuart Armstrong, and Milan Cirkovic in 2017. This hypothesis suggests that advanced alien civilizations might be in a state of hibernation, not to escape the heat, but to wait for the universe itself to cool down. But the universe is already pretty cold, right? Well, yes and no. While the average temperature of space is a chilly 2.7 Kelvin, that's about negative 270 degrees Celsius, or negative 455 degrees Fahrenheit. In cosmic terms, we're still living in the hot early days of the universe. Here's where things get interesting. The Aestivation Hypothesis is based on the idea that advanced civilizations would eventually transition into a post-biological state, existing primarily as information processing entities. For such beings, the ability to compute efficiently would be paramount. Now, here's the kicker. As the universe expands and cools, it becomes more efficient to perform computations. The colder the environment, the less energy is needed to maintain the same level of computation. It's like how your laptop runs faster and uses less power in an air-conditioned room compared to a hot beach. So, according to this hypothesis, super advanced alien civilizations might have done the cosmic math and realized that they can accomplish more by going into hibernation now and waking up in the distant future when the universe is cooler. They're essentially maximizing their computational resources by waiting for better cosmic weather. Math checks out. The potential for computation in the far future is vastly greater than what's possible now. We're talking about gains of billions or even trillions of times more computational power for the same energy output. But hold on, you might say, wouldn't we see evidence of these sleeping giants? Not necessarily. If they're truly in a state of hibernation, they might have minimal energy outputs, making them incredibly difficult to detect. However, like all these theories attempting to solve the Fermi Paradox, the Aestivation Hypothesis has its critics. For one, it assumes that all advanced alien civilizations would make the same choice to hibernate, which seems unlikely given the diversity we see in nature. Even on Earth, not all animals choose to hibernate or estivate. Moreover, even if some civilizations chose to hibernate, we might still expect to see evidence of those that didn't. After all, it only takes one ambitious alien race to light up the galaxy. Still, the Aestivation Hypothesis remains an intriguing possibility that can't be entirely ruled out. It's a reminder that when we're dealing with timescales as vast as the age of the universe, our human perspective of time might be severely limited. Let's shift gears now and consider a theory that's a bit closer to home. Imagine for a moment that we're not latecomers to the cosmic party, but actually among the first guests to arrive. This is the essence of the early bird hypothesis proposed by researchers at NASA's Jet Propulsion Laboratory. This hypothesis suggests we might be one of the first technological civilizations to emerge in our galaxy. I know, it sounds a bit egocentric, doesn't it? But bear with me, because the reasoning behind this is fascinating. Think back to your high school chemistry class. Remember the periodic table? Well, in the early universe, it was a lot simpler. We're talking primarily hydrogen and helium, with barely a sprinkling of heavier elements. Those heavier elements, the ones essential for rocky planets and complex life as we know it, they took time to form. Here's how it works. Stars are cosmic factories. They take light elements like hydrogen and helium, and through the process of nuclear fusion, create heavier elements. When these stars die, especially in spectacular supernova explosions, they seed the cosmos with these heavier elements. Now, here's the kicker. It took time for enough stars to live out their lives and create sufficient quantities of these heavier elements. According to the early bird hypothesis, the conditions for life as we know it have only been ideal for a relatively short time in cosmic terms. The theory is supported by a growing understanding of exoplanets and the conditions necessary for life. We're finding that many older star systems might not have the right composition to form rocky, potentially habitable planets. But wait, you might say, even if we're among the first, shouldn't there still be others? Well, yes, but remember the vastness of space and time we're dealing with. If technological civilizations are only now becoming possible in cosmic terms, and they're spread out across the galaxy, it's conceivable that we simply haven't had time to detect each other yet. It's like being the first person to arrive at a party venue. You know others are coming, but for now, the place seems empty. However, like all theories, the early bird hypothesis has its limitations. Even if we're among the first, the galaxy is so vast that we might still expect to see evidence of other early civilizations. After all, even a small head start in cosmic terms could mean millions of years of technological development. Moreover, this hypothesis doesn't account for the probability of life forms radically different from our own, which might not require the same elements we do. Still, the early bird hypothesis offers an intriguing possibility. If true, it would mean that humanity has an unprecedented opportunity and perhaps responsibility as one of the first technological civilizations in our galaxy. Now, let's take a sharp turn into more ominous territory. Imagine a dark, dense forest at night. You're standing in a small clearing, aware that you're not alone, but unable to see or hear anyone else. You know that making a sound or shining a light could attract attention, but is that attention friendly or hostile? This chilling scenario is the basis for the dark forest theory popularized by Chinese science fiction author Cixin Liu in his novel The Dark Forest. It's a theory that takes the Fermi Paradox and gives it a sinister twist. The Dark Forest theory proposes that the galaxy is silent because all intelligent life is hiding. But why? The reasoning goes like this. 1. All life desires to stay alive. 2. There's no way to know if other life forms have good intentions. 3. Given the ability to destroy other civilizations, it's safest to destroy them before they become a threat. In this scenario, the galaxy becomes like that dark forest, where every civilization is both hunter and prey simultaneously. The safest strategy? Stay silent and hidden. It's chilling though, isn't it? That the cosmos might be filled with advanced alien civilizations all cowering in the dark, afraid to make their presence known. But it gets even more unsettling. According to this theory, if a civilization is detected, it faces immediate destruction. Any civilization advanced enough for interstellar communication or travel would also be capable of interstellar destruction. So the moment you reveal yourself, you become a potential threat that must be eliminated. This theory offers a compelling explanation for the great silence we observe. It suggests that the reason we haven't detected alien civilizations isn't that they don't exist, but because they're intentionally hiding just as we should be. Before you start advocating for shutting down all of our radio telescopes, let's consider some of the criticisms of this theory. For one, it assumes that interstellar warfare is feasible, which may not be the case given the vast distances involved. Even at light speed, it would take years to reach even the nearest star system. This gives any detective civilizations ample time to prepare defenses or launch counterattacks. It also assumes a level of paranoia that may not be justified. After all, resources in space are abundant. There are countless stars and planets out there. Would advanced civilizations really need to fight over them? Moreover, this theory assumes that all civilizations would arrive at the same conclusion and adhere to the same strategy of silence. Given the diversity we see in nature and in human cultures, this seems unlikely. However, the Dark Forest theory does highlight an important point. We don't know what the motivations or behavior of alien civilizations might be. That uncertainty is a crucial part of the Fermi Paradox and something we need to consider as we continue our search for extraterrestrial intelligence. So next time you look up at the stars, remember, in this dark forest of our galaxy, silence might just be the sound of survival. Now, let's shift our perspective entirely and consider a theory that challenges our very notion of how advanced civilizations might progress. Forget about spanning outward into space, but what if the path of progress leads inward instead? This is the core idea of the Transcension Hypothesis proposed by futurist John Smart. This hypothesis suggests that advanced civilizations don't expand outward into space, but rather inward into increasingly dense and efficient substrates. I know, it sounds wild, but bear with me, because this theory is as fascinating as it's mind-bending. The idea goes like this. As civilizations advance, they move towards smaller scales, faster speeds, and higher energies. think about our own technological progress. We've gone from room-sized computers to smartphones that fit in our pockets. Our devices process information faster and faster, and we're constantly seeking more efficient energy sources. The Transcension Hypothesis says that this trend continues to its logical extreme. Eventually, advanced civilizations might compress themselves into microscopic black holes, effectively disappearing from our observable universe. Now, you might be thinking, why would anyone want to do that? Well, it turns out there can be some compelling reasons. First, these inner space environments would offer vastly more computational power and energy efficiency than outer space. Remember when we talked about how computation is becoming more efficient as the universe cools? Well, the environment near a black hole is already incredibly cold in terms of its ability to support computation. Second, these black hole-like environments might serve as gateways to other universes or dimensions. If true, advanced civilizations might be emigrating to realms beyond our ability to detect or comprehend. The hypothesis is intriguing because it aligns with some observed trends in technology, such as getting smaller and increasing energy efficiency. It also offers an explanation as to why we don't see evidence of alien megastructures or interstellar travel. They're not out there because that's not where advanced civilizations go. However, like all Fermi Paradox solutions, it has its criticisms. For one, it assumes that all advanced civilizations would make the same choice to transcend, which seems unlikely given the diversity we see in nature. It also doesn't explain why we don't see civilizations in the process of transcending. Surely, we should be able to detect some signs of this process happening somewhere in the observable universe. Still, the Transcension Hypothesis offers a provocative alternative to our usual assumptions about the trajectory of advanced civilizations. This, that as we ponder the Fermi Paradox, we need to be prepared to radically revise our expectations about how intelligent life might develop over cosmic timescales. So the next time you look up at the night sky and wonder where all the aliens are, remember, they might not be up there at all. They might have gone an entirely different direction, inwards to realms we can barely imagine. As we've journeyed through the mind-bending theories, from hibernating aliens to civilizations transcending into black holes, one thing becomes clear. The Fermi Paradox continues to inspire some of the most creative and thought-provoking ideas in modern science. Each of these hypotheses, the Aestivation Hypothesis, the early bird hypothesis, the dark forest theory, and the Transcension Hypothesis, pushes the boundary of our understanding and imagination. They challenge us to think beyond our human perspective and consider the universe on truly cosmic scales of time and space. It's important to remember that while these theories are fascinating to consider, none of them have been proven. The truth is, we still don't know why we haven't found evidence of alien life. It remains one of the greatest mysteries in science. But that's what makes this field so exciting. Each new theory, each new observation, brings us closer to understanding our place in the cosmos. And who knows, perhaps the solution to the Fermi Paradox is something we haven't even considered yet. As we continue to explore our universe, both through powerful telescopes and creative thought experiments, we get closer to answering Fermi's profound question. Whether we're alone, among the first, or simply haven't detected our cosmic neighbors yet, the implications are staggering. So, what if we solve the Fermi Paradox? The answer might reveal not just the nature of alien life, but fundamental truths about our own existence and the universe we inhabit. But our journey doesn't end here. In fact, we only scratched the surface of this cosmic mystery. All Sci Fi What If. I'll be exploring more cutting-edge thought experiments and their implications for our understanding of life, intelligence, and the nature of the universe itself. Until then, keep looking up, keep questioning, and remember, in a universe as vast and ancient as ours, the only limit is our imagination. Thank you for joining me on this cosmic journey. If you enjoyed this video and want to see more, don't forget to like, subscribe, and hit the notification bell to stay updated on my latest videos. And let me know in the comments, which of these theories do you find most compelling? Or do you have your own explanation for the Fermi Paradox? Until next time, this has been All Sci Fi What If, reminding you The greatest mysteries of the universe are waiting to be solved. Keep exploring.